All right, so let's start on this one. So the first thing we want to notice is that square root of x squared minus, since that's just 3, it's not a perfect square, but we can make it square root of 3 squared, is in the form square root, let me move that over some, square root of u squared minus a squared, which we know is equal to a secant theta. About the right tangent. Why am I mixing those two up? Am I mixing those up?
No.
I am mixing those up. Let me make sure. I hate having to look at you.
Plus or minus a tangent theta, isn't it?
Yep, u squared minus a. Yep, a tangent theta. Why am I mixing those up? I should have known better.
Plus or minus?
Well, with that one, we don't know what our x value is yet. Yep, so we kind of leave it plus just in case.
Okay.
Since it's subtracting a constant squared, why wouldn't it be secant? This isn't,
Trying to think, where did I? Hold on, I think it is.
is it tangent when it's added?
No, you said with integrals involving u squared
Minus.
square root of u squared minus
A squared, yep.
let u equal to let u equals a secant theta.
Yeah.
Then the square root of u squared minus a squared would be equal to plus or minus a tangent theta.
Yeah.
Yeah.
Thought so. Nope, it's secant.
Yeah, this is.
Yep, that, yeah, okay. U equals a secant theta.
U is
Okay.
equal to a secant theta.
Okay.
So
Long
the
day.
whole square root is equal to plus or minus a
Yeah.
tangent theta.
You have me doubting myself. I knew this already. I'm like, okay, maybe I messed up.
Maybe we should just skip this chapter. If you're confused, imagine how you feel.
Well, the difference is this is my third class today, so.
You should know it by heart now.
Yeah, I do. I knew it by heart walking in this morning, but by the time you get done teaching calculus and
Right.
trig and all that, you get.
How many times have you said secant and tangent today?
I thank you. All right, so in this case, our u is equal to x, and our a is equal to square root of 3. Okay, so we can go ahead and draw a triangle. Okay, so we know that tangent of theta is u over a. So you have adjacent, and our u is equal to x. Oh, wait a minute. Square root of 3. Opposite over adjacent, yes. Okay, so that's square root of, oh, wait a minute. Opposite over adjacent, so let me just write that out. Okay, so that would be, okay, why do I have a different triangle on mine?
Because your a tangent theta needs to be a secant theta.
Yep, it was a secant theta. Oh my goodness, I need to go home and get a nap.
I thought we had just said that it was tangent.
It's
Nope,
supposed
wait a
to be a secant theta.
Nope, u is the a secant theta. That is
U is
a
secant
tangent.
theta.
Yep, u is
The
a
whole thing is
secant
supposed to be
theta.
tangent theta. You had it right.
Yep, so this actually should be secant. Okay. Oh, goodness.
No.
Yep.
No.
Yep, because remember for number 3, square root of u squared minus a squared is equal to, if you let u equal a secant of theta.
If u is equal to a
Yep.
secant theta.
Because remember, if u equals a secant theta, then divide both sides by a, so secant a of theta is equal to
U over a.
Yeah.
Okay. Yeah, so u squared minus a squared is tangent.
Yep, that's tangent.
Okay.
Until you have me doubting myself, just It's been too long of a day for you to make me doubt myself. All right, so u is equal to a secant theta. So that's how we ended up with that. So now, instead of opposite over adjacent, secant, so cosine is adjacent over hypotenuse, so you have hypotenuse over adjacent. Okay, so you have u over a, so u is equal to x, which is hypotenuse over adjacent. So this gives you square root of x squared minus 3 square root of 3 squared, which is just 3. Okay. Nobody say anything else, because I'm pretty sure this is it, and I don't need anyone else mentioning anything and have me going,
It all makes sense.
Okay.
We're good.
Pretty sure it's.
Just accept it.
Don't
Just-
say
just-
it.
even if it's wrong, leave it. Just accept it. It's like, but yeah, this is right. All right. So now we're going to use the triangle to find x, square root of x squared minus 3, and our dx. Okay. So we already know that secant of theta is hypotenuse over adjacent, which means that a secant theta is equal to the hypotenuse, which is x. Okay, and we know that a is equal to square root of 3, so you know that x is equal to square root of 3 secant theta. Okay, so we found the first part of it, so we're good there. Okay, so now we're looking for our square root of x squared minus 3. We can kind of get the square root of x squared minus 3 over square root of 3. So we could find it. Okay, so that means if we have, oh, actually, since we have our x, we might as well find our dx, just to stay in order. Okay, so dx is going to equal square root of 3 secant x tangent x dx. Yeah, theta. Oh, you get the idea. There you go. D theta. Like I said, you get the idea. Okay, so we know since tangent theta is opposite over adjacent, okay, so you have your opposite over adjacent, so that means tangent theta is equal to square root of x squared minus 3 over square root of 3. Which means square root of x squared minus 3 is actually equal to square root of 3 tangent theta. Okay, so now we have our x, our dx, and our square root of x squared minus 3. We just go ahead and start replacing stuff. Okay, so square root, integral of square root of 3 to 2. Our square root of x squared minus 3, that's just 3 tangent theta. Okay, over your x, that's just, where is it? Square root of 3 secant theta. Oh, did I leave that square root of 3 out for the tangent theta? Yep, left out my square root of 3. Okay, so my x, square root of 3 secant theta. And your dx, where is it? Is square root of 3 secant theta tangent theta. With respect to theta. Okay, so we just go through and we just replace everything. Yep, and we simplify it. So these two cancel out. These two cancel out. These two just become tangent squared. We can bring that right out to the front. Okay, so from square root of 3 to 2, and bring our square root of 3 out there. we have the, oh, I already put the integral. Tangent squared theta. D theta. Okay. Now we already know when we have a even and positive tangent squared, we have to convert it.
Adding all that into this,
So you have square root of 3 to 2, secant squared theta, minus 1. D theta. Okay, so we know the integral of secant squared theta is tangent theta. So you have square root of 3 times tangent theta minus the integral of 1 is just theta. But this is from x equals square root of 3 to 2. So we now have to, this is where the u substitution would come in handy. Because if you convert that back to all of this, then it would be pretty complicated trying to solve all that. Okay, so we know that, oh, sure. Oh, make sure I have that one. Okay, so this is from x equals square root of 3 to x equals 2. So we're going to have to convert it. And I'll draw a little box to kind of separate it. So when x equals 2, remember your x equals 2, you have secant of theta. You just divide both sides by square root of 3. Oh, can you see that? Yeah, there you go. So you have secant theta equals square root of, well, 2 over square root of 3, which is 2 square root of 3 over 3. Sorry about that. All right, and this is true when theta is equal to pi over 6. Uh-oh, forgot my theta. Okay, now when x is equal to square root of 3, secant theta is equal to square root of 3 over square root of 3. Excuse me. Which means that secant theta is equal to 1. So that means your theta is equal to 0. Okay, so for square root of 3, replace that with 0. For 2, replace that with pi over 6. Okay, so you have your square root of 3. Tangent theta minus theta from 0 to pi over 6. Yes?
If for the exams, like, instead of using the triangle, let's say we already have it memorized,
Mm-hmm.
Are you going to count off for that, or?
Oh, you mean if you had to?
If we don't draw a triangle, or you?
Oh, no, if you don't draw the triangle, it's completely up to you.
Okay. Just I don't know. Just making sure.
Nope, the triangle is just convenient if you're going to convert your final answer. That's when it's convenient. All right, so we just go ahead and solve this one. So you have square root of 3 tangent pi over 6 minus pi over 6 minus tangent 0, might as well say square root of 3. Oh, yep. Tangent of 0 minus 0. Okay, so we know that tangent pi over 6 is just 1. So you have square root of 3, nope, square root of 3 over 3. I'm running out of room. Again, all that wasted space up top. Let's see if I can squeeze it up here. I'll move that up a little bit. Okay, so you have square root of 3. Tangent pi over 6 is square root of 3 over 3. Minus your pi over 6. And everything else just becomes 0. So we can leave that there. Okay, so you end up with 1 minus square root of 3 pi over 6, which if you plug that in, you could have left it there if you wanted to, but if you plug it in, it's 0.0931. As your final decimal answer. Okay, so either one of those answers would have been just fine. All right. Any questions on this one? All right, if there are no questions, I will see you on, what's the date, Wednesday? Yep, Wednesday. I'll see you on Monday.
No, today's actually
And you know what? I'm sitting back getting ready to listen to you. That's the sad part about it. You're getting ready to tell me it's Thursday. I was about to say, maybe he's right.
I'm still confused about my question earlier. So my partner next week had print off like a practice exam for like last exam. So this is what we just learned today.
Nope, it's a little bit
How is it different? Yeah,
because
that's where I'm
on
confused. I'm
this
wondering.
one, you would have had a value there other than 90 squared. So if you had, say, 3T there, then those usually match, and you would have used a secant.
But like, isn't this?
This one's different because
Can't you rewrite it like that and then use one of the three forms we learned?
No, you can't, because you won't have another trig function
Yeah.
to cancel out.
Okay.
that's it.
Okay. So that's
It's a little bit different.
okay. I was
So
really
that
caught
was
up on that.
This is just, when you simplify this, you're gonna end up, this is just gonna turn into like the form for the arc sign.
Yeah.
Okay.
That's what that's gonna turn into.
Okay.
Just a little bit different.
Gotcha.
There's very minor changes.
Yeah. After you said that, I was caught. Thank you very much.
No problem.
Can I have the sign-in sheet, or is it too late?
Oh, there it is.
You might have borrow your pencil.
Oh, there you go.
Thank you.
How do we claim this extra credit?
Oh, just hand it in and.
Do I need to sign my name or anything on it?
Oh, yeah. Oh, you
Probably should.
The extra credit?
Yeah.
Since when was that extra credit?
Oh, send it in the announcements on Canvas.
Oh, I probably didn't look at it.
Yeah. Oh, there you go.
Is when's I due? Today?
Yep, because it was what is that, the seminar downstairs.
I didn't go to that.
Yep, they had one Monday and one today. So. Oh, you have two? All right, thank you.
You said, do you know when you're gonna have the exams done? Graded?
Probably the Friday afternoon or Saturday morning at the
Oh,
latest,
okay.
yeah.
How's it looking so far?
Oh, I haven't even looked
I
at
haven't
it.
looked at it.
You go over the process of how you change the bounds.
Oh, sure. So just the new substitution. So here, just starting from the top, these are all based on with respect to x.
Right.
So whenever with respect to x, that means if you had all these still as functions of x, you can just plug them in and replace them with x.
Right.
But since we don't have any x values here, we could have just replaced these with x terms, but then you have some really crazy looking terms, so it's easier here to just go ahead and convert these two.
Right.
Okay. So since we know that x is equal to get this one right. There we go. Okay, so x is, what was that equal to? AC can't say that.
You're still